Okay, we're looking at Lab 2, which is the application of stacks and queues. This is the Google Doc that explains this. There are a couple of, I think, interesting and maybe semi-challenging problems here. None of them are too crazy, and I think we've walked through most of the tricky parts last time to see how the balanced parentheses problem and the postfix calculator problem both nicely map onto a stack. The other three questions have to do with queues. And I'd like to help develop those today, both in the idea of it and to begin coding. And I'm going to go, we'll go in regular order. All right. So number 3 is a prayer scheduler. So we're modeling the way that a friend of mine has this prayer discipline. What she does is she has a set of prayers that she writes down on index cards. Like all of them have like a scriptural basis. So she has like a scripture and then the prayer that kind of builds out from the scripture. But the scheduling of it, she uses note cards in a box. And when I saw this, I realized, that's kind of like a queue. That might make a good data structures assignment. So this is what she does. She has a category for answered prayers. When prayers are answered, she puts them in the back. Here, answered. She determines that prayer was answered. Yeah. She also then has prayers that she prays daily, which is just a few of the prayers that she wants to pray every day. So she's got them in a daily category. And then the rest of the prayers that she wants to pray, she's divided into 12 or 14 different days of the week. So that then each day she does the daily prayers plus whatever number of the non-daily prayers is next at the front of this list. So then, like, looks like today, from this picture, she would do all the daily prayers and the stuff in number 5. When she's done, she would put all the daily prayers back in the daily spot, and then she would take number 5 and its tab and put it at the back behind what would be, looks like number 4. Does that make sense? And so this way, she's got more prayers than she can pray daily, but she's decided she's definitely doing these prayers every day, and she'll eventually rotate through all of these. And for her process, it even means like she doesn't even have them by day of the week because she had more than she could do in 7 days in a week. So if she's up to 12 looks like the number. But also, if she ends up not doing a prayer walk or a prayer time that day, then she just resumes where she was the next time. You with me? Like, they're not exactly, 5 isn't always Monday or whatever. So I thought, what would it look like to model this in code? And when I thought about that, I came up with this. For one, we definitely have the idea of we've got a model of prayer, and I'm imagining if we were going to do this in code, every item that's in a database would have an ID. So we're going to have a unique ID that's an integer. Prayers, we're going to say have a category, they have a scripture, they have the text of the prayer. A Boolean, is it a daily prayer or not? A Boolean, is it answered or not? And basically a timestamp. When was the last date time that this prayer was prayed? That makes sense for the prayer? So this is really like, we're not going to be doing, this is really just storing information. The logic is in this prayer scheduler. So this prayer scheduler is a queue-like system. It's not exactly a queue. And this prayer scheduler is we're going to define one main method that will accept a number of prayers. It's only going to get unanswered prayers. Remember, once a prayer is answered, it goes kind of in that different category. It's always going to get all the daily prayers, those where is daily is true. And then any number beyond the number of daily prayers, it'll get the least recently prayed that many prayers. So let's imagine that you had 10 daily prayers. If in the method, what is the method? Get prayers. So if we say get prayers 20, we're going to get 20 prayers. We're going to get the 10 daily prayers plus the 10 least recently prayed prayers, which we are going to store in a queue. So those are going to be the front 10 items in the queue. Does that make sense? So to me, the queue really does represent that part of it exactly well. When we're done, you can imagine we're going to put the dailies back in the daily box, but we really don't even have to model that because we're always going to be storing what the dailies are. But importantly, I think I should have the word non here. We're going to take the non-daily prayers, those last 10, and we're going to put them at the back of the queue. So that then, does that make sense? So in our system, we don't have the idea of a chunk of, like she did it with a number 5, and there was the 5 group, and the next day she did the 6 group. Ours is more fluid than that because we can just say, hey, today I want to do 27 prayers. So that would be your 10 daily, if there were 10 daily, plus the 17 prayers at the front of the queue. Does that make sense? So the queue, in my mind, this actually really does help us solve this problem of this ordering, because we're always going to be wanting to do that in order. I think I have some kind of gross stuff that I've defined here. If the number of daily prayers is more than the number of prayers, so if you have 10 daily prayers and the user asks for 5 prayers, then my rule is they still have to take all the dailies. So you're going to give them 10 when they ask for 5, if they ask for a number that's less than the number of daily. So that's kind of a weird edge case. I just said that. Additionally, we're going to update the last prayed date to the current date and time whenever they're prayed. That would be if the dailies and the non-dailies will keep up with when was the last time you kind of touched them, prayed them. So the properties for this data structure, I think, are we'd like to have a list of prayers that are the daily prayers. This is a getter, so we're going to handle adding stuff to daily prayers in a different way. We have another list of prayers that only has a getter, that is the non-daily prayers. So this is the one that this needs to be handled in a very queue-like fashion, but we're going to keep the queue on the inside and expose a list to the outside. And then lastly, we'll have another list of prayers that are the answered prayers. To be clear, the daily and non-daily would then be the non-answered prayers. You can imagine they're kind of both in that same category. Does that make sense? I'd like to know how many daily prayers there are, how many non-daily prayers there are. And then in addition to get prayers, which to me, the get prayers is kind of the centerpiece of this whole thing. But I would also like to be able to add a prayer. When you add a prayer to this whole system, you're adding a new prayer, then you've got to determine, is it already answered? If it's already answered, then put it in answered. I don't know why anybody would do that, but let's handle it if they do. Second question is it daily or non-daily? If it's daily, then we add it to the end of the daily list. If it's non-daily, then we add it to the end of the non-daily list. And then there's a method to say, hey, this prayer with this particular ID has been answered. I want to mark this as answered. So basically, find it in the list of dailies or non-dailies and move it to the other one. And now that I'm looking at it, I realize we really need public void move to daily that takes in a prayer ID to move something from wherever it was to daily. And then you probably need a move to non-daily. I think moving in between the categories actually would be an operation that you'd want this system to support. Okay. Questions on this? It's like a little convoluted, but it's also like real life. Like this is what she really uses this box. And if you were going to make this a digital system, which she has considered, then you really would need to walk through these steps to go through the same process that she goes through. So to me, it's not arbitrary. Like this is a real world problem, and this is how you would map it into software, I believe. You wouldn't necessarily use a queue, I think. You could simulate a queue with just a list, but I think it's more fun for our class if we actually make it a queue. Questions on this? This came from Dr. Clark's wife, but that makes it more personal. So this is her process. And I really respect it too. I am not this disciplined of a prayer, and I really admire how intentional she is in her life to do, I think, prayers well. So kudos to Fallen. Okay, number 4 is like a classic brain teaser, data structure, interview kind of question, where they create false constraints just to make things harder. I would like to create a method called reverse first k, which takes a q and an integer k and reverses the first k elements of the q. You with me? So if we had this q 4, 5, 6, 7, 8, 3, 2, 1, and we were going to reverse the first 3. Notice in this case, I'm saying this queue. This is the back of the queue. This is the front of the queue. So 3, 2, 1 is at the front of the queue. You have to know which one's front and back, and that's not necessarily clear from the way I wrote it here. Okay? So I'm imagining that the queue goes, well, would you say that from right to left? The end of this thing is the front of the queue. So that means that I want to find the first 3 things and reverse them. I don't think I did this right. I think, yeah, I don't, that's wrong. I would say, hang on, like, that what I meant for this to be is you reverse them, but they still go at the front of the queue. So that would be 1, 2, 3. Oops. It reverses the first k elements of the given queue. Yeah, I would say if you're going to put them on the end, then that's a different operation, and I would explain that differently. So this is what it would look like. Let's do another example because I was so messed up on that. Oops. So let's create another queue. Just choosing some random numbers. to put in that queue. And I don't know. Let's do a big number and see what happens. Okay, so if this is the, I call this the back, and this the front. I think having those labels is actually pretty essential. I think that's what got me confused last time. Huh. Okay, so let's find the first 6. Yeah, 1, 2, 3, 4, 5, 6. 6, 7. Those are the 6, yes? So what I'd like this to become is 6, 7, 10, 9, 8. 7, 6. Did I do that right? Does that make sense? So get the first things out, reverse them, and then put those reverse numbers at the front of the cube. How are you going to do? Well, the other thing that I'm asking you to do here is only use stacks and queues, not decks, to do this. That's the arbitrary, let's make this harder than it should be kind of thing. It's like we're going to pretend like all we know are stacks and queues. I think even with my change here, though, it's definitely possible. Can we think of an algorithm that would help us do this? So definitely, if we have this like temporary stack, stacks are really good at reversing things. So if you push on, if we DQ, Q, U, E, U, E. So it's hard for me to not write this in code. I want to like, if I push on DQing n times to a stack, then I'm going to get a stack that looks like, just imagine the stack is going to equal something like, let's imagine now that the top of the stack is to the right. I don't know which way you want to go. So if you push on, I think I want to do this easier one, if I may. So I would push on a 1, I would push on a 2, push on a 3. Now if I pop those off, they're going to be in reverse order. So now what could I do? I need to get them back on the queue. How do you get something on a queue? I could queue.enqueue. That's what she called it. And it would put it at the back of the queue. So that's not exactly right, but it's kind of close to right, isn't it? So now the queue is equal to, if I may, 1, 2, no, 3, 2, 1. No. I want to pop off the 3. Oh, hang on. Let me put it in. Once I've DQ'd those, that's the queue, right? I've DQ'd three numbers. So this is my queue. So if I push them, if I NQ them, then I would NQ the top of the stack. Hang on, did I say the top goes this way? Yeah. I can't remember. I'm going to have to put a thing here. That's the top. Yeah? So if we pop from the stack, we're popping off a 3. Yeah? Let me push that on. Or NQ that, sorry. We pop off a 2, do that, pop off a 1 and put it there. So the good news is I have 1, 2, 3 in the right order, and I have 4, 5, 6, 7, 8, 4, 5, 6, 7, 8 in the right order. The bad news is I really want this chunk of numbers on the other side of that. How could we do that? So Ryan's saying we could DQ and then NQ it. So take the guy at the front and put it at the back. Yeah? Is this closer to what we want? There's now an 8 next to the 1. That's what we wanted. So then let's do that again. Yeah? DQ the 7 and then NQ it. We're getting closer? So then we DQ the 6. Sorry, did it reverse. DQ the 5 and NQ it. DQ the 4 and NQ it. Does that make sense? I would call this operation rotate. You see, we kind of rotated the queue. I guess you could also call it the, it's a very biblical operation. The first shall be last is what's going on there. So it's a very Jesus operation of inverting the ordering of the system. And I guess now the last shall be first as well. So I believe, having gone through that, this is the same as, as this. So it's still a kind of, you see it's an interesting little brain teaser, but on the whole, even if you just have stacks and queues and you can't just arbitrarily insert, you can do this operation. And I do, like, to me, this is the one that is the most like an interview question, a silly interview question, but you are definitely smart enough to do this. So when you see a question like this on a technical interview, I want you to kill it in a good way, because you know you can do this. Just working some stuff around. So sort of the algorithm idea here is, so pop the first, last. No. DQ the last n items in the queue and push them to a stack. Push them on a stack. And then rotate, no, then push, no, then NQ the stack to the end of queue. And to be clear, it's really redundant of me to say NQ to the end, right? Because NQ, that's the only place they could go. And then, I didn't really write all this out here. And then rotate the queue. And you have to think about how many times do you have to rotate the queue? You definitely do this n times and you do this n times if I'm reversing the length of the queue, the original length of the queue. Okay. Yeah. which I guess, let me think, would be the, sorry, if you've already in-queued these, then it is the current length of the queue minus, well, minus n, because at this point the stack's empty as well. But so it's the length of the queue minus n is how many times we rotate.
Order the queue. No, not that.
I did both of these steps. I kind of did this rotate the queue in place. So now this one line represents both of these operations. It's a little unclear. But on the whole, I don't want to make it too clear. I don't want to make it too easy for y'all. Y'all got to do a little bit of thought. All right, the last one is I want to make a simple abstract data type for a playlist music player. And what I want us to be able to do, I think the essence of this is you want to have two queues. You have a queue that is the playlist that's currently played, and you could do operations on it, like add to the playlist, which adds to the end. You could remove it from the playlist. You could play next, which adds to the front of that playlist. But there is also another queue, which is like your song history. And so when you play a song, you essentially take it off of your playlist or your now playing list and add it to your history. Maybe however you want to think about that. So there's actually two queues going on there. Okay, so now let's move to code because we've talked too long and now we need to code hard. That's right, said with so much gusto. Okay, balance parentheses. You ready for this? Let's see. Which one of these is hardest? Balance parentheses, postfix calculator, prayer scheduler, reverse first K. Maybe. Definitely, I agree that I have defined the music playlist the worst. So maybe that's a fine one to start with and to define together. Okay, so in the music playlist one, I'm going to open this up, right click, and I'm going to create a new file. And let's call this, kind of want to call it music player. Maybe it should be called music queue. No, music player. .cs. So I'm going to have a public class music player. Okay. Oh, and I probably want this to be in some kind of namespace. Yeah. Music playlist is the namespace for this project. I'm going to copy it from that program CS and put it at the top of that. Okay. So this is our music player. This is my suggestion for the overall architecture of this thing. I think we want to have, essentially, within our music player, we want to store two queues. They're both going to be private, though, because we're not going to let things external to our class just change these willy-nilly. You know willy-nilly? It's an incredible phrase. I don't know another way of saying willy-nilly. Haphazardly. That sounds really fancy. We need to get to the bottom of this. What are some other ways of saying willy-nilly? I assume that's how you spell that. Oh, I didn't mean to have thinking on. That really wasn't deserving of thought. Okay, we'll come back to that. So I'm saying that we're going to have a private queue for, like, would you call it up next or upcoming? Okay, then we'll just call it up next. As I think about this, I realized, what is the thing, the object, that is going to be in a queue? If it's a music player, it's a song. I think we need to make a song.cs to model songs. So again, I'm going to have my namespace of, what's it called, music playlist. And I'd like a public class song, like so. And let's put in just a couple of properties that we think songs should have. So what are the essential properties of a song, in your opinion? Don't you call it a title? What would you call it? The song name, song title? I would think you call it a title, don't you think? Okay. Another property that all songs have would be an artist, right? Can you think of anything else? Length. Okay, I like that. So let's call this int. One way some people might denote this is to say it's duration, but go ahead and embed the unit of duration in the name so that we're always reminded, oh, that's not in minutes, that's not in milliseconds, that's in seconds. Okay, anything else? If you think about what you would see, like you might have cover art, but I kind of don't, to me the cover art is actually a property of probably the album that it's on. And I don't want to even deal with albums. We're not going to worry about, we're not worrying about sound files. We're just really modeling the data associated with this. Our lyrics. Do we want to store lyrics in our system? No, we do not. To me, this looks like the essential stuff. If you imagine what would show up in a player. Okay. Okay. I'm only going to do this, but this is all I'm giving you. This is all I got. So, sorry. This is a date time, release date, get set. Sure. Why is this mad at me? Oh. I think I really want to have a public string, or public override string. Yeah. Override to string. And be able to just, in case we print out one of these songs, I would like to be able to see what it looks like. I think that's going to be useful. So again here, I want to return a, you remember this thing, the way you can put string interpolation here. Title dash artist. I think in parentheses I'm going to have duration. And then, there. Bar? You like bar? Nope. I'm getting stuck in JavaScript. Thank you. Release date dot I'm going to just put release date dot year and just extract the year from the release date. I don't care about those other things. Okay. It may not be the best way of converting the thing to a string, a song, but it'll work for us. Just to make it more readable if we print any of those out. So there's our song. Okay. So now I know that this up next queue should be a queue of song objects. Notice this queue here, if you hover over, you can see this is the queue object that comes out of system.collections.generic. So this is the queue that's Microsoft already made for us. So if you need a queue, most languages would have one built into the system library. I think because this is internal, this can be a field. It doesn't have to be a property. Okay, so we're getting there, guys. We're really getting there. I have an up next queue, and I also have, I'm going to call it the history queue, which is this is the history of songs that I've played. And to me, you see how, like, I think if the music player I use has this same structure. I assume yours does too, where you can see what played in the past or what's going to play in the future. And as we're playing, we're essentially going to take out DQ from the front of the up next queue, and then we're going to add that to the is it going to be the front or the back of the history queue? We have to think about, I guess it could be either way. We just have to be thoughtful about like how you display it. So it might be that when you display it on screen, the up next queue is always shown from back to front.
Because let's say you have like 5 songs. You play the first song. You want to go back. You want to play latest song you made.
Okay. That's a possibility. I'm also thinking we might be able to see this as a deck. And I suspect that the built-in queue object is a deck, and it's going to let us operate at the front or the back. So let's hold that. I really wanted this to be a queue thing, but it could be stacks and queues. So let's do this. I need a constructor. You know CTOR? CTOR is a snippet for a constructor. So I've got public music player parameters. And for now, I don't even think I'm going to have any parameters. But in my constructor, you could do this in any place. You could do it here or in the field initializers. I need to say that up next is equal to a new queue of songs. Yeah, and I need to say that history is a new queue of songs to give that memory. Okay. We need to be able to add a song, because public void add, and we pass in a song here. What does it mean to add a song to this music player? It should go into up next. And where should we add it? I think it should go to the back. If it's a queue, that's where we could put it. So there's an enqueue method that's defined on this object. I think that's it. Okay. let's have a public song I think I want to call it next song, and I would like it to be a getter. So this is a property, not a method. I'd like to know what's the next song that's going to play. Does that make sense? So, yeah? So in this case, this is a property, so it's like, we're going to access it like it's a field without parentheses, but it's going to run this code, this getter. This is going to be a read-only property. What is the next song? It's up next dot is the front of the queue, right? And okay, good. There is a peak here. Returns an object at the beginning of the queue. You remember peak? For a property like this, that's so simple of an implementation, do you remember there's a shorthand for doing this? Instead of doing all this junk, for something that simple, I can just say arrow up next dot peak. And then you don't need any of this. So if you use the arrow syntax, you don't have to have the curlies, the get, or the return keyword. You okay with that? I mean, on that note, you could even say, you could simplify this as well. I believe in this, instead of having all that, we could write this as an arrow function and just do this and delete that. I don't know, to me, I don't like converting, I don't know, I like converting properties to this syntax more than method. But this is equivalent, so I feel like I should show it to you. What do you think? Do you like this better? Okay. What about this? If I were to say public void play, so this is the play operation. So this is equivalent to me pressing play on my music player. You know, triangle. Can we think about what would happen if we're going to model the idea of playing this? So we need to get it out of up next. Do we need to add it to anything? For what we're modeling, we add it to history. I was thinking now, you might say that there's like a currently playing song that's almost between history and up next. You know what I mean? I guess it's past, present, future, and that would be the present spot. And there can only be one in the present. Or you could always say, based on this history thing, it's always the thing at the back of the history queue. I don't know. I'm really doubting the idea of history being a queue. Seems like it should be a deck. But I don't think .NET gives us a deck, does it? DEQUE? So you want to do it in a stack? Is history a stack? Yes, it is. I think I want to be looser here, Ryan, and everybody. I'm so torn on this. I can't exactly predict the future, but I almost wonder, should this just be a list? With a list, we could add to the front or the back. We could iterate over it. What is it we're going to do with the history? I guess the history, you don't even get to reorder the history. So, okay, let's try stack and see if it works. So I need to change this to stack. Back to play. I want to get the current song. So this would be like song, current song is equal to up next dot DQ. Yeah. So we get it out of the queue, the up next queue, and then we add it to the stack. And this is called the history stack. History dot, surely it's push. And I want to push the current song onto that. I actually think here, I would like to say, let's let the play method actually return the song. We're not really going to, sorry, that's little s song. Oh, no, it's current song, sorry. We're not really going to have a program that's driving this. We're mostly just modeling it, so it's hard to say how we would use that. Okay. A couple of things that y'all came up with, which was excellent last time, were the play next. This add to queue is basically what we called add. We have a remove from playlist. Okay. Okay. Play pause. Loop song, go back. Okay. Also, I guess we get this. Number one, hats off to Garrett. You exactly said what ChatGPT said. Haphazardly, randomly, indiscriminately, erratically, chaotically. Helter Skelter. I'm going to start using Helter Skelter. Pell-mell, hit or miss, slapdash, scattershot, harem scarum. Is this... Have you heard that? I have never heard that. Higgledy-piggledy. It's like the requirement to have this meaning is to have two words that are nonsense words that rhyme. Wow.
No, you're right.
Just words that rhyme. Wow. That is really interesting. Wow. Harem scarum. Okay. If I wanted to get a count of how many things were in my playlist, I think we can do it like this. How many things are in this playlist? Is it the number of things in the history? Is it the number of things in the upcoming? Is it both added together? Okay. So in this case, we would need to return. I'll have to write the keyword return. This would be up next dot, I think it has a count. Yeah. The number of elements contained in the queue plus history. Surely it's called a count too. Yes. So if this is our definition of count, I could see it either way. It should at least, in my mind, be the up next, and maybe it's everything. And then maybe there's another one, public int, songs remaining, or count remaining. What would you like? Do you like that? Not really? Let me do it the other way. History count. How many are in our history? And this would just be an arrow function of history.count. Count. And honest, I like putting my properties up earlier because usually properties are kind of boring and methods are, more interesting because they have functionality. I guess technically that's one too. This doesn't matter. This is just me trying to, I don't know, organize my code. Okay. What about this? I believe I'm definitely going to want to have something like public song next, or I'm wanting this to be a method where I'm actually saying, actually skip to the next. Should I call that skip to next? It's when you press the play button with a bar, like go to next song. What would you call that? Y'all must have had it on here. Skip song in queue, next. So can I call it next? Skip.
Skip is the important. Next implies that it's just.
But what about when you go the opposite direction? What's the word for that? I kind of want it to be similar. But you don't say skip to previous, do you? So that's what I think. To me, this is clear to call this next. And then public song prev. So in this case, what is it I want to do? I go to the next. I'm going to
Because song, it's basically.
It is. Yep. So maybe let's just call play then, since we've got it. This would be return play, because it returns something. So that's dequeuing from next, pushing that onto the history, and returning that. But what about previous? What would previous be? This one's more interesting. Is that right? I feel like we want to get the thing at the top of the history stack. So now we have the previous song, and I want to return that song. I'm pretty sure. But I need to do something else too, don't I? So this is where I am feeling a deck would almost be better here. Go with me on this. We went through an example from the homework where we were able to completely change the order of the queue, but keep them in order. And I call it a specific operation. You remember that? Remember rotate? If we had rotate, and you could rotate by a number of items, could we do this? So if we had a rotate, and I would say rotate looks like this. Some int in. Would this work? So we need to say up next dot in queue the previous song, and then we need to make it the front. Yeah. He says length -1. I'm just pulling numbers out of his wazoo, perhaps. What, Tristan, you got thoughts? I think it has to be exactly the right number. And if we're one off, it won't be right. This is the Q assignment, bro. All right, Tristan makes a good point, which is if we just used a list, we could just stick it on the front or back, whatever that would be. And we wouldn't have to rotate all those things.
We can consider this sort of like the reverse.
Yes. Will you do that for me, Tristan? Okay. You're so kind to me. Thank you. So I'm going to have I think I want to make, do we want people outside this of our class to be able to rotate the songs? I don't think so, but I could be wrong. But I'm going to say this is a private void rotate int in. I need to put an actual number here. We'll come back and fix this. Let's make this function. We've kind of already seen this, right? How would we do this? So we're going to say up next dot enqueue, up next dot dequeue. That feels weird. I'm going to put this in a for loop because that's the way I count. So this will cause this many rotations. Something one might want to do is to say if up next dot count is less than or equal to 1. You see what that's saying? What is rotating a queue of 1 doing? Nothing. What's rotating a queue of 0 doing? Nothing. So let's at least not do that. There is another edge case that we should probably consider because we actually would want it. Yes. If we had a really, really big number, like if we were going to do something, imagine we wanted to rotate a queue of 10 things 100 times. You with me? It's going to rotate the whole thing through 10 times. But we kind of already know what it's going to be, right? It's going to be the same as rotating it through once, which is actually the same thing as rotating it through 0 times. Are you with me? Does that remind you of modular arithmetic? Yeah, mod could help us out here because we can take a giant number and break it down to what it effectively is. Does that make sense? What about this? What if I wanted to rotate by -1? Should that be allowed? Negative numbers? Brandon's like, no. And your last name is Stack, so you speak with some authority. But what if I wanted to go back one? That's exactly what previous is, isn't it? I mean, we could go forward 9 or back 1. So it almost to me feels like it might even be useful. You think? I'll let y'all think on that. I think there's a little bit of math we could do here that would make our life a lot easier to handle large N and negative N and still get what we've got. Okay, so this is what I'd like y'all to do. Would y'all be willing to do the test on Thursday instead of Tuesday? Okay. 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 So we'll do the test 1 on Thursday, and I really would like Tuesday to do some cleanup on this, and especially the music player one that's not really fully defined. But I do need you to do the other ones basically on your own. Bring intelligent questions to class on Tuesday. And then also we'll have a time for some things that I think you probably should know. Maybe we'll spend 10 or 15 minutes talking about things you should know before the test so you can do really well on that. Okay? All right, y'all have a good day.